So in this example, we are going to talk about how to go through a whole stoichiometry problem, but take into account limiting reactants. Okay, we're looking at aluminum and how it reacts with oxygen. Okay, when aluminum reacts with oxygen, the reaction produces aluminum oxide in the following reaction. We're looking at a lot of aluminum oxide today, I guess. So 4Al reacts with 3O2 to produce 2Al2O3. So that's aluminum, oxygen in the air, aluminum oxide. If 10 grams of Al, let's underline that 10 grams. If 10 grams of Al is reacted with 35 grams of copper, if 10 grams of Al is reacted with 35 grams of oxygen, how many grams of aluminum oxide would be produced? Determine the limiting reactant in the process. So I outline this very clearly for you on the exam. If you've seen that already, which you hopefully have opened, I outline these 4 steps in one of the problems. So now you get to go over an example that goes over that exact same scenario. So hopefully that problem will be more clear and easier to do. So first thing we're going to do is convert given amounts into moles of both what we're given. We're given aluminum and oxygen. So we will need to do what we did in the beginning of the lesson, where I went over that in the launch of how to go from grams into moles. We're going to do 10 grams of aluminum divided by the molar mass of aluminum, which we already know is 26.98. Divide out the grams, and then divide the numbers. 10 divided by 26.98. We get 0.371 moles of aluminum. Save that for later. 35.0 grams of O2, not just one single oxygen, it's 2 oxygens. So that would be divided by the molar mass of O2. Since oxygen is 16 and we have 2 of them, that will be the molar mass of 16 times 2, which is 32 grams per mole. We'll divide both those numbers. We'll get 1.09. So we're going to take these numbers and we're going to do what we did in the last problem and figure out what the limiting reactant is and what's in excess. Notice in the last problem, you can rewatch if you need to real quick, I looked for excess. I think sometimes it's easier because if you know what excess is, if you know what you have too much of, then the other reactant has to be limiting. So let's first, okay, what's the mole ratio of Al and O2? Well, I see 4Al and 3O2, so the ratio is going to be 4 to 3. So if I divide 4Al over 3O2, I get 1.3. 1.33. Let's see what happens if I divide these two numbers and see if it's a proportional amount. So I have 0.371 moles of Al. And I have 1.09 moles of O2. So 0.371 divided by 1.09, I get 0.340. All right, let's compare these two numbers real quick. 0.340 is way less than 1.33. All right, it's less than, right? That's what that symbol means, the little arrow thing. So what this means is, okay, since the part of the fraction that would cause our answer to be less, in this case, would be the numerator. Okay? If the denominator were to go down, if 1.09 went down, then the fraction would be a bigger fraction. Okay? You can think about that like, well, what's a bigger number? A half or a quarter? All right, a half is more than a quarter. All right, 1/2 is bigger than 1/4. That 4, bigger denominator makes the fraction smaller. Okay, so in this case, the 0.371 moles of aluminum, that's a clue that tells us that aluminum is going to be limiting. We have excess in the denominator. Okay? The answer, when we divide that out, is less than what we have in the mole ratio, and that's because we have a big denominator, okay? Excess in the denominator. Which means limiting has to be in the numerator, okay? 0.371 is limiting, okay? So that means aluminum is limiting. So what we're going to do now is go forward in our problem with aluminum. Okay, it's limiting. So we need to proceed with steps 3 and 4 using the mole ratio between limiting reactant and unknown to find moles of unknown. We're looking for moles of Al2O3. So we have 0.371 moles of aluminum. We can think of it kind of like taking that answer from, the first problem, that 0.371, and bringing that on down. Okay, so 0.371 moles of aluminum is going to be brought on down. So we have 0.371 and we got to use the mole ratio. Okay. So we'll divide that by an X to figure out number of moles of Al2O3. So here's what we'll have. 0.371 moles of Al over X moles of Al2O3. We'll set that equal to our mole ratio. Our mole ratio is 4Al to 2 Al2O3. 4 to 2. Zooming out just a bit so we can kind of see the flow here. Okay, we went from here, okay, to determine that aluminum is limiting. So we're going to take this number and use it instead of 3. Okay, so let me zoom back in. Sweet. So we got a 4 to 2 mole ratio. 4 Al to 2 Al2O3. So how do we solve for X? We cross multiply. 4 times X is equal to 0.371 times 2. 0.371 times 2. We're going to divide both sides by 4 to get X by itself. X equals 0.371 times 2 divided by 4. So we get 0.18 0.55 moles of Al2O3 into our last step. Step 4, converting moles of our unknown to grams. So going back to our launch, we multiply our moles by the molar mass. Okay, 0.1855 moles of Al2O3 times the molar mass. So do the math real quick. You'll find that the molar mass of this compound, Al2O3, is 101.96 grams per mole. Cancel out moles. Leave the grams. And so we get our answer. So we get 18.9 as our final answer. That's going to be in grams of aluminum oxide. Awesome. So just a real quick look at the whole process. Okay, so we start up here, okay, and figure out go from grams of both reactants into moles, find the limiting reactant. Once we have that, we use the mole ratio between limiting and unknown, okay? And then we figure out the final answer in grams and multiply by the molar mass. I hope this lesson was helpful. I will be as available as I can be during the Zoom hours. If I'm not available, email me. I'll get back to you as soon as I can, okay? I'm here for you, so whatever support I can give, I am going to do my very best to give. I know right now it is challenging. I know in this distance learning format with video lessons, it's not always as easy to gain the knowledge and to understand. I don't have immediate feedback if my explanations are helpful. And so I really need you to take that extra step and ask me via an email or something, just in case you are not sure. Don't hesitate. The communication is what's going to help both of us in this. So please tell me if anything is unclear, okay? Looking forward to chatting with you via email or Zoom. Hopefully I will see and hear from you tomorrow. Have a great night, guys. Bye-bye. Have a great day, guys. Bye-bye.